This is the setup for your friction experiment. We will be investigating how much force is the maximum static frictional force acting on the friction block, and also the kinetic friction on different surfaces. For this example, we have the paper as our surface. Other groups will work on metal, plastic, and the carpet. So your friction block should have a mass or a load of 500 grams, and then it must be connected to your force sensor, which is of course connected to your sparks. Okay, first of all, you need to calibrate and make sure that if you are not pulling the string, the amount registered in your sensor is 0. If not, then you just have to press the 0 for a few seconds. And there you go, it's registering 0 now. Okay, and then you press this one. There are two choices, the positive and the negative. So you just press on the positive and the show button will become active. So press that one and it will go to the next screen of the graph and time for your x-axis. There is also the play button that will be shown, and you have to change the setting here for your timer. Make sure that you set it to 20 to make it more accurate or more data points. Okay, so our goal is to pull your friction block as it moves against the paper surface. Make sure that this is horizontal so that you have no other force on the component in the y direction. So you just pull it slowly until it starts to slide, and then try to pull it at a constant force when it is already set in motion. And do not forget, you need to press the play button. Okay, so let's try that one. Okay, I'll press the play button and then I will start to pull. Okay, and it's a little bit tricky on that one, and then press stop. Okay, once you have your sample data, you might want to try and do it for yourselves few times before you get your good set of data. Okay, so I press the graph button and it shows the submenu for the graph. You try to show this big screen and you will be able to see that, see, I have there like a pause or a stop when I was trying to pull it, but you can ignore that one because what we are interested is that maximum pull. So you can see over here the force of friction is starting to increase until it's have its maximum value here, and then this is approximately constant pull that I was doing when it was already set in motion. Okay, and so that's what we wanted. So if you try to read that data, that's corresponding to 3 newtons, while this one is approximately 2 newtons. If you want to see the actual value of that one, there's a way to do that by just pressing this arrow to the right twice, and you will be able to see your table. So if you are not sure about that values on the peak and the constant one, then you can scroll it down and see how much is the maximum. So you see over there, there's 3, and then it becomes a little bit, you see, playing between 1.9 to, and this is approximately the constant value that we're looking for the kinetic frictional force. Okay, so if you want to go back to the graph, you can just scroll it twice, and then you will be able to take a picture of your data or graph using your tablet. So don't forget to do that one, so that when you do your next trial, you can do 2 or 3 trials depending on our time and how fast you can do it, but 2 is the minimum. Okay, now the other variations that you're going to do is by changing the load. So instead of 500, you can increase it to 100, for example. So another 100, and then you just do the same procedure. The other thing that I want you to investigate is what's the effect if we turn the surface into the narrower side. So will it give you the same force? Will it require the same amount of force in order to pull it, and so just be careful. Okay, so you do that one. You can disregard this data. You just go home and say no, and then you will be back into the first screen that I showed you a while ago. So again, let's just double check. It is on the 0, and then the positive value, we wanted that one, and then show again your graph. Okay, so we'll try to pull, and then press the play button, pull it as horizontal as we can. Okay. See, until it is moving, and then we will stop. And then what do we do next? We press the graph button, and then we wanted to see the blow up values. So again, see that one? I'm getting better in here. So we have the peak and we have the approximately constant value. So there you go.